In section 8.2, what we are investigating is if there's a case in the ANOVA where we reject the null and find that we have difference in at least two of the groups, how we can figure out which groups are the groups that differ. It may be all of them, it may just be two of them, and so we want to know which ones. So what we do is we look at confidence intervals for two groups at a time using this formula here. It's the difference in two sample means for whichever two groups we're comparing, plus or minus a t critical value. The t comes from using a degrees of freedom of n minus k, which was our degrees of freedom between before. And we also want to account for the fact we're going to be doing multiple intervals. So the confidence amount that we use when we look up the t in StatKey is 1 minus the error divided by c, where c is the total number of intervals we're constructing. Then we take it times the square root of MSE, which is the same as MSW, times 1 over each sample size. So we're going to look at this formula for the finger tapping problem where we did find significant differences in at least two of the groups. A few things we already know is that the three sample sizes all were equal. They were all 10 in that problem. We also have all the sample means from before, so we'll be using those again. Our MSW or our MSE, those mean the same thing, from that finger tapping problem was 4.967. And then we also need to look up our t. Our degrees of freedom n minus k was 27. And when we look up t, if we want a 95%, but we want this overall rate, what we do is if we have a 95%, our error is 5% or 0.05. So the amount of confidence we actually use is 1 minus 0.05 divided by c. C is the number of intervals we're doing. If we have three groups, we need to compare group 1 and group 2. We need to compare group 1 and group 3, and we need to compare group 2 and group 3. And so with three groups, we have three comparisons. That's not always equal. It's not always equal to the number of groups, for here it is. So this C will be 3. So if we take 1 minus 0.05 divided by 3, we get about 0.983. So that's the level that we want to use with degrees of freedom of 27, and we are looking for a t. So in StatKey, we go to t, we enter a 27, we'll click two-tail because we're doing two-sided intervals, plus or minus, and we change the 95% to this new adjusted 0.983, and we can see that the t we have at the bottom is plus or minus 2.544. Okay, so what our intervals look like is you take the difference in the two sample means. For the first two, it was 244.8 and 246.4. Add or subtract our t times the square root of MSW of 4.967 times 1 over sample size and 1 over sample size. And these are both 10. They can differ for the different groups. This one gives us an interval of negative 4.136 to positive 0.936. And then we do that for each of these. So a lot of it looks the same. This will be 244.8 was the mean for group 1. Group 3 was 248.3. Still plus or minus the same t. And the rest of this is actually all the same. So provided that you have the same sample sizes in all these, this last term will always be equal. And then 246.4 and 248.3 for groups 2 and 3. And then this again is all the same. So really what changes from interval to interval is the means that you're looking at and then the sample sizes if they do happen to be different. So these other two intervals are negative 6.036 and negative 0.964 and negative 4.436 and 0.636. And these are comparing two means. As we saw in chapter 6, when we're comparing two means, we're trying to see if we have 0 in the interval or if we have all positives or all negatives. The intervals that do contain 0 are not significantly different. This one has a 0 and this one has a 0. They are not significantly different, those means. This one, however, that I'll star here, this does not contain 0. It is all negative. So since we have that mu1 minus mu3 interval is all negative, that tells us that mu1 minus mu3 is less than 0, or that mu1 is less than mu3. So in terms of the caffeine amounts, what we're seeing is that we have a significant difference in the group 1, which is 0 milligrams, and group 3, which was 200 milligrams, with the population mean number of finger taps being less for 0 milligrams than for 200 milligrams. We do not have significant differences between 0 and 100 or between 100 and 200. So the fact that we rejected the null in the ANOVA and found we had some significant differences comes from the fact that it's between the 0 and 200 milligrams.